We're looking at section 8.4, finding the volume of spheres. So if you look over to the right side of the page, in the top right corner, you'll see the volume formula, which is over on the sideboard and it's on the reference sheet on the regions. There's a few examples that are done that you can kind of take a look at, but we're going to look at the 3 examples at the bottom of this page. So, kind of moving down, I'm going to write the formula up at the top. In this case, it's 4/3 pi r cubed. We're going to look at the first one. And again, what we need is the radius in this case. So we got our radius. In this case, the radius is 12. So I'm going to take my formula, and I'm going to substitute the number 12 in for r. And I'm going to write this in terms of pi. So I'll take my calculator, turn it on, and type in everything except for that pi symbol. So we got 4/3, and then we have parentheses 12, and then we use the caret symbol for the exponent, and then I can put the 3 in. So our answer in terms of pi is 2,304 pi centimeters cubed. And then again, if you want to find an answer to the nearest tenth, which again is not an exact answer, you just have to type in that value you got, and then hit second, and then the caret symbol for the pi button. And that'll give you an answer that would be rounded. So I'm going to round this to the nearest tenth, which would be, in this case, 7,238.2. And then the measurement, again, centimeters cubed. So again, there's 2 ways you can express these, and they usually ask for both on the test. Now the next part we're going to do, number 2, you're going to see that we have half of a sphere. So we got half of a sphere, it's kind of cut in half, and then there's a cylinder also to go with that. And there's a double marking at the 6 over here, which means that that's going to be 6 also. So what we're going to have to do to find the total volume is we're going to need our formula that we just used, which in this case is 4/3 pi r cubed. But because it's half, we're going to have to divide it by 2. So it'll be 4/3 pi parentheses 6 cubed, and then I'm going to put that over a fraction and then divide that answer after I get it by 2. And then I'm going to have to add that to the volume for my cylinder, which in this case would be pi 6 squared, and then the height, which would be 6. So I'm actually going to erase that plus sign. But we're going to take these 2 volumes that we find and add those together. So I'll use my calculator over here. First thing I'm going to do, type in that expression. And I'll keep this one in terms of pi. So we got 4/3, and parentheses 6 cubed. I'll hit the enter button, and then divide that answer by 2. So for the first part, I have 144 pi, and then I'll find the cylinder in terms of pi. So I'll have, in this case, 6 squared times another 6, which will be 216, and then again pi. So I'll add these 2 together, and then it'll give me an answer of 360 pi, and then I'll use my measurement centimeters cubed. And like I said before, if you want to change it to nearest tenth, just got to put that 360 pi in the calculator. Now the last one we're going to look at, number 3, it says a volume in a can, and it said not including the tennis balls. So I'm going to erase some of the work I just did for 1 and 2. So I got some space to work for 3. So what we're going to have to do for 3, I'm going to move that up so I have a little more space. We're going to have to find the volume of that cylinder. We have all this space inside. I'm kind of coloring in right now. We got all this space inside the cylinder. that we need to find the volume for. So what we're going to have to do is figure out the volume for that cylinder. That's our first step. So I'll use my pi r squared h like I just did in the last question. And then what I'll have to do is subtract it from the volume, in this case, of those spheres. I have two of them. So whatever I have for the spheres, 4/3 pi r cubed, whatever I get for that, I'm going to have to multiply it by 2 because I have two of them in there. So over on the left, I'm going to write this out. So for my cylinder, it looks like I got a radius of 9 on my cylinder and then a height of 26. So my first step is going to be to do pi 9 squared times 26. So I'm going to go ahead and throw that in the calculator. So I got 9 squared, parentheses 26. So for that volume for the cylinder, my volume is 2,106 pi, and then I'll include the centimeters cubed on my final answer. The next thing I'm going to do is do my volume for my spheres. I'll do that in blue. So in this case, for that, it's going to be pi with my 4/3 in front, and then the radius is 6, and that's to the third power. So I'll type in my 4/3, 4 divided by 3, then I have 6 to the third power, which is 288. And now again, because I have two of those spheres in that, I'm going to multiply this by 2. So for the two balls, the two tennis balls or whatever they are in the can, we have 576 pi. So now if I want to find the area of that space, the remaining space, all this part I had colored in, I'm going to take those values and then subtract them. So I will do 2,106 minus 576, and I'll get a final answer of 1,530 pi centimeters cubed. So a little difference between 2 and 3, because 3 is asking for remaining space, so we have to subtract. But 2 has two different shapes, and like we did before with area, if you have two different shapes, you want to make sure you add those areas or volumes together at the end to get the total.